Hello everyone, myself Shashidhar and our team group is team 1. These are the team. These are our team members who contributed to this project, and we work mainly on the spam detection dataset. The goal of this project is to classify the text messages whether it is spam or ham. So the main objective of this project is to train a machine learning model. Uh, as the dataset is a labeled dataset, we used supervised machine learning technique, classified machine learning algorithms, especially with we mainly focuses on decision tree. So when coming to the dataset, our dataset is contains two columns. One is the labeled dataset, which tells us spam or ham, and another is text column. So when coming to the project workflow, first we have read the dataset by using the CSV reader. Here we can see after reading the data, there are some unwanted columns, column 2, column 3 and column 4. Uh, so to remove that unwanted columns, we have taken care in this column filter. Before that, we converted this text column to the documentation format because this text may be the raw data. So this raw data we converted to the document format, and later here we can see still these columns are there. After this column filter, we removed all this just by excluding those things and including the wanted things. Just we need the v1, which is a labeled column, and the document, which is a predict independent variable. Okay, text column. And after that, and we used the pre-processing steps for the text column. uh, yeah, when you open this meta node, first we use the punctuation eraser. This punctuation eraser node removes the punctuation and clean up the symbol which actually do not carry meaning for the classification. For example, there may be the exclamation mark, question marks, all those things like that. These type of things, it removes the punctuations and clean up the symbols. And after that, we use this number filter, which removes the numerical tokens like 4 numbers or random digits, and and some tokens are too short or some tokens may be too long. uh, so this may create some irrelevant information, so such type it eliminates this n character such type of irrelevant words which are too long or too short. And stop word is some words do not create meaning for the spam detection. For example, like the if you keep these things, these are unrelevant, unnecessary, creating the extra column. So we will take care to remove all such type of things, some words. And case converter, here we converted to one case, lowercase, sorry, lowercase, uh, and after that is pre-processing. We shuffle the data to take care the bias from the original ordering, to remove any bias from the original ordering. Then we splitted the data into 70% and 30%, 70% to the testing and 30% to the 70% to the training and 30% to the testing. That we can see the first partition and second partition. The first partition contains 3900 rows and second partition contains 1672 rows. And for the testing data, we again have done some pre-processing. Bag of words first we used. This bag of words um, pre-process the text document column into the bag of words representation, where each document represents by the frequency of its terms by using the TF, like uh, that most common words. The intention is to get to know the most common words. The intention of this pre-processing tool is to get to know the most repeating or common words, which helps us to get to know the pre-processing, how many times that certain words are repeated, to know the spam, to classify the spam, which words are most common. So first we converted this text as to the string, this term as a string. We converted the string, and after that we used a group by. This group by helps us the string terms and counts how many documents each term appears, and helping to identify uh, that particular string how many times it is frequently occurring. And at last we used this TF, calculate the frequency of each term, calculate the frequency of each remaining term in each document, and converts the filtered backup words into a numerical feature matrix, which helps us for modeling. Okay. After that we used, even if you see here, pre-processing 2, we can see only column 5, only 5 columns. After using this document vector, every word converts into a column, like binary encoding it will do for every column. So after these many words, because of these many words, it is converted to the 1008 columns. And after that we used this category to class. Here we do not have a label, so we need label, right? For that it will create label. It is how it is creating label means, here in CSV reader, when we go this CSV reader, sorry, in documentation creation, here we can see the like category as we have given as v1. This v1 as a labeled, based on this it will give the convert the this category data to the label data. That we can see here in column filter. If you see the documentation class alone, it will like ham spam, you can see, right, that one. So that is the extra column we are observing came, so 1009. And independent variables are 1008. Okay, this is a thing. And in code manager, for visualization purpose, we are given the color here as a documentation class. Ham is green and spam positive negative. Okay. And after that we have given this uh, decision tree. And in this decision tree you can see the visualized representation uh, here. The tree, we can observe the tree correctly separates the ham and spam. In first it classifies as a 95% and 55%, as it will go on. If you check now, later 94, 93. So it is clearly separating the ham and spam using future holds, which is likely come from term frequency, maybe, or document values. Uh, we can clearly say leftmost path ends in pure harm group, and rightmost path isolates very few spam, shows a good classify separation. And the same thing we also followed for the testing data set, applied the same pre-processing steps, documentation vector applier for the independent variables, and converted to the category class uh, 1009, and applied the color manager, and we use this decision tree predictor. Okay. uh, this decision tree predictor we can observe by using the column filter, by using giving the prediction documentation class is our labeled, and document is the text, right? So by using these three we can observe like how it is predicting documentation class and prediction. So we perform this model evaluation by using this scorer. If you use this scorer only, if 47 plus 19 66 66 are misclassified, so it is good, it is classifying very well. And if you see the ROC curve also, you can see area under curve is 919. It means 91.9% of probability are correctly distinguished between harm and spam messages. Like good it is. So the conclusion of this project is this project is successfully implemented a text classification pipeline in NIMNI to distinguish between the spam and harm messages using pre-processed techniques such as punctuation removal and case normalization and documentation vectorization. And we also trained a robust collection model. So decision tree provided an interruptible um insights into a three predictive features. While the model performance also we tested using the ROC curve, which I have shown a 91%, which indicates a high accuracy in distinguishing spam from legitimate messages. Overall, the workflow demonstrates a powerful and no-code solution for real-world text analytic tasks. Future improvements could include incorporation and more advanced ensemble models and real-time deployment capabilities. So this is our spam detection, which helps customers to uh, the main intention of this project is to help the customers to help the customers to aware of spam messages. Yeah, this is our project. Thank you.